with that, I introduce our two folks that are going to share this session. Christoph Meinrenken, Associate Research Scientist at Earth Institute, and Tamar Eilam, IBM Fellow, IBM Research.
Thank you, Sharon. Hello and good morning, everyone. Thank you, Sharon, for the introduction, and thank you to all the organizers of this event. I'm Christoph Meinrenken. I'm a research scientist at the Earth Institute and Columbia Climate School, and I also teach in sustainability management. Tamar, it's a pleasure to have you here with us today. You are an IBM Fellow at their Watson Center in upstate New York, and you're leading their cloud computing and climate smart supply chain work. You and I met as part of an IBM-funded small research project on publicly shareable product carbon footprints. We'll define that in a moment. And that's really part of the larger collaboration between IBM and Columbia around transparency and efficiency of carbon footprint quantifications. But before we get into the weeds of this half-hour's topic, may I ask you, Tamar, to tell us a little bit about you, your professional journey, and really how you ended up with this particular portfolio of responsibilities at IBM. I think you were educated in Israel, right?
Yes, Christoph, thank you. And thank you, Sharon, for the nice introduction. Yes, I did my PhD in computer science in Israel on algorithms and complexity. And I joined IBM Research in 2000 because I wanted to work on practical problems. I have 20 years of experience in research in cloud computing. And I must say I was pretty much ignorant when it came to climate, just too many other things to worry about. But this all changed for me in 2019. What happened is that I attended a computer science conference, ICSI, in Montreal, and I went to a keynote presentation by Professor Steve Easterbrook from Toronto University about climate. And what he said in that presentation shook me to my heart. He talked about how the grave UN report in 2018 was too conservative in the analysis. And this is because they did not consider the interrelationship between different systems, such as the permafrost melting, which is by itself a worrying phenomenon, leading to the release of potent methane that was buried under the layers, thus accelerating this vicious cycle. Steve repeated three things that each one of us can do. He says, one, talk about it, which is what I'm doing right now. Two, participate in democracy. In other words, take any opportunity to vote. And three, make it your job if you can. Long story short, when I came back from the conference, I could not stop thinking about it. I was really obsessed. I asked all around IBM, what are we doing about climate? I learned a lot. I got pulled into some customer conversations and even went to Singapore to meet with a client. And in 2020, we formally launched a research program called Future of Climate, and I joined the leadership team. So this is my story, and I hope I'm going to go into more details today about what we're doing in Future of Climate. And Christoph, let me turn it back to you. So I'm curious, how did you end up working on climate? I believe your PhD is in physics?
Yes, and your comment on permafrost and tipping points, as we refer to them, is you're preaching to the choir. So yes, I was educated as in physics and math, and within that, sort of the passion I found was building models, both physical and statistical models, often hybrid. And then I applied this passion, talent, I hope, to different fields, computational neuroscience, financial engineering. And when I came to Columbia, I worked on various challenges around carbon management. One of the questions we were working on was how to build a modeling capability that can assess and then reduce the greenhouse gas emissions, or carbon emissions in short, that are associated with everyday consumer products. So before I get to my next question for you, Tamar, let me just tee up for the audience a little bit what it is we are working on to make sure we're all on the same page with regards to terminology. Also, by the way, I think it's already been mentioned, Tamar and I will speak for about 15, 20 minutes, and then there is time for Q&A from the audience. So please use the Q&A feature in the webinar. The last few minutes will be moderated questions that we're looking forward to answer. So you've probably heard of carbon emissions by country, by company. Probably most of you also have heard of the carbon footprint of a product. So that's if you buy a t-shirt, the question is who made it? Was fertilizer being used in growing the cotton? How are you going to wash it, with cold water or warm water? All that contributes, as you know, to the carbon emissions associated. So recently, there's been a lot of momentum in this field. Unilever has come out with a big announcement last year that they want to do the product carbon footprints of the 70,000 of their different products. Allbirds, much smaller company, has product carbon footprints, even Apple for their iPhones. So when the Data Science Institute suggested this topic to Tamar and I, we've thought a little bit about really the three requirements around transparency. From a fundamental point of view, we felt to be transparent about data, first of all, you have to be, the company has to be able to measure the footprints in the first place, right? At scale for thousands and thousands of products. Then the company has to feel comfortable sharing that information, otherwise it cannot be transparent. And lastly, someone has to be on the other side to care and understand about the data that you're telling them, because otherwise transparency doesn't work. So my question for you, Tamar, is with these three things that we came up with in mind, can you just elaborate a little bit more on what elements in your work and recent specific developments in data science you find fascinating and how they relate to these three aspects? Where can science and engineering help, and where maybe not?
Yes, thank you, Christoph. A fascinating question. I think, first of all, let's just say the most important thing we need to do to combat climate change is to reduce the carbon in the atmosphere. So everyone understands that. But to reduce carbon atmosphere, we first need to measure it, as you said. We must measure in order to be able to hold businesses accountable. And essentially, this is a data problem. Data that must be shared across organizations in order to calculate, for example, the carbon footprint of a product across the life cycle, which includes all phases performed by different entities, such as manufacturing and packaging, distribution, use, and end of life. So first of all, what we need is a clear methodology and standards that everyone agree on to do this type of calculation. And mostly the GHG protocol provides this. And then we need a way to share the results of the calculation. We need a platform that people trust. And blockchain has some nice properties that can be used, such as the immutability of the data. And last, we need to be able to perform the calculation more efficiently. See, I consider myself a mathematician, but I'm also a software engineer by training. And in that capacity, when I see manual and spreadsheet based, which is how these calculations are performed today, I also, let's say it positively, I also see an opportunity. My team in IBM Research is working on a carbon accounting engine that can be seen as an implementation, a programmatic implementation of the relevant standards. And it interfaces, what it does is it interfaces with data sources, such as sensors, satellite images, and enterprise databases in order to acquire the data and then perform the calculation in a much more efficient and trustworthy way. And this is, I think, where you said it right, Christoph. You and me had the initial sort of meeting of minds. Your earlier work was about applying AI to do this sort of calculation in in a large scale to address a collection of thousands of products. Would you like to talk more about this and your current research?
Yeah, sure. I'm going to try to keep it short because I want to have enough time to ask you questions, but just a couple of comments, again, maybe on those three aspects. On the first, capability to quantify, exactly like you said, we had this sort of meeting of minds. The original research was done with PepsiCo around 10 years ago, and then it was later used at Nike as well. So it's really algorithms that use ML and AI tools to read data from companies' enterprise resource planning systems, bill of materials, etc., to then automate these complicated carbon footprint calculations, and we call that capability fast carbon footprinting. On the willingness to share, so that the buzzwords there are, as you know, blockchain, also distributed ledgers, etc. And one thing I learned there that fascinated me is working with companies. When you tell them to share their carbon footprint, carbon footprints can be very revealing. They have a lot of sensitive information built into them. So one branch of this around blockchain, distributed ledgers, etc., I understand is that there can be very smart ways of controlling that the data doesn't get shared with everyone, but only on a sort of need to know basis, certain parties, certain divisions in a company, etc. I think we're going to hear more about this also from Jay and Ramesh in the next session. So stay tuned for that. And then lastly, just a couple comments on awareness and understanding. First of all, people need to be aware, and we do not just have to thank researchers for that, also artists, journalists, you know, Greta Thunberg, etc. Second, for me, there's a fascinating side of data science, which is really about visualization. So for example, a couple of years ago, I worked with a women-led startup out of from two Columbia alums called CoClear. We did a hackathon with the Data Science Institute, and from that emerged something which we call the Carbon Catalog, which is an online interactive visualization of close to 1,000 carbon footprints. And then lastly, just as an opportunity for me to also thank IBM for the funding for this small research project, the publicly shareable product carbon footprints, that gets a little bit to this concept of, yes, you have to find a uniform data structure that you can share, everyone understands. And also you have to simplify to make it understandable, but you cannot oversimplify. So for example, back to the t-shirt, if you tell the consumer your t-shirt has a carbon footprint of X, a single number, that's not enough, because what if the consumer says, yeah, but I'm buying the product and I'm going to wash it with green electricity in my washing machine and cold water. So I need to know how that's going to change the carbon footprint. So there's a balance between granularity, simplicity, and oversimplification. Can I ask you another question, Tamar?
Of course.
So since you have worked more in the area of cloud computing and also carbon accounting, what you described earlier, is there maybe sort of like one particular fact or phenomenon you came across that really surprised you, where you were like, wow, that stood out and that kind of stuck with you?
Yes. One fact that I discovered, which was quite astonishing, is the cost of AI, artificial intelligence. Did you know that training some AI models take the equivalent of 5-car lifetime emissions? That is like quite remarkable. So this is the conundrum right here. I believe AI is a very powerful tool that we can use also around climate. For example, in IBM research, we are using AI in order to accelerate scientific discovery, and in particular, find new materials that can be used for carbon capture, which could really be a breakthrough. However, I believe that with power comes responsibility, and as technologists, we have responsibility to improve the efficiency of AI with innovative systems and software design. So this is a very, very fertile ground of research. And let me just mention quickly just another gap that I want to allude you that I discovered. So this is not like an astonishing, but this is a gap that I discovered, which is in quantifying carbon footprint of workloads running in a multi-tenant commercial cloud environment. This basically goes back to our theme of transparency, because there we actually have no transparency. Essentially, a user in a cloud environment have no access to data such as the power consumption of servers she's using. This means that the responsibility in calculating carbon emission of client workloads is on the cloud provider, since they're not enabling you to do that computation. Then there are other challenges pertaining to the fact that workloads, as you know, IBM has a cloud. So now obviously what I'm working is to help them do that, help them quantify the carbon footprint associated with workloads of our customers running on our cloud. But it's tricky because in a multi-tenant environment, workloads share resources. So now you need to split the power that comes into the server between or across all the workloads that are using that server. And that's not so easy to do in a fair manner. So that's sort of my current focus of my work.
Yeah, fascinating to listen to you. I sort of have this challenge in my work that I like working interdisciplinarily or transdisciplinary, whatever you call it. So sometimes I get questions about the energy consumption in data centers, for example, also from Columbia. We ourselves have data centers, of course. And even in that sort of small segment, you can see the many different disciplines that data science touches on, whether it's from a using AI to fine-tune the air conditioning loads in the data center to reduce electricity consumption that way, right? Or more sort of, in my uneducated view, bread and butter traditional computer science, how can you improve the chips and reduce the electricity consumption of the chips themselves, also writing code, load balancing, etc. So it's just nice to see how the Data Science Institute, which really operates not just in the engineering school, but across all of Columbia University, right, can bring these different interests and disciplines, capabilities together. Maybe tagging onto that, my next question is borrowed from our former Dean of Engineering, Dean Boyce. You just met the wonderful new interim dean earlier today. One thing I always appreciated is how she finds in these forums the time to also address our role as educators, not just researchers. So my question for you, Tamar, is what would your advice be to students, or maybe to the teachers of students, for someone who listens to you now and thinks, wow, Tamar, she's cool, she found this niche of very interesting work that also helps the planet. What advice would you give them? Are there particular fields to study or particular career paths to follow?
Yeah. So the advice that I always give is, first and foremost, you need to follow your passion. Because if you don't follow your passion, you're going to get bored. And my passion is now in climate. But when I started my career, I sort of stumbled upon this problem of the gap between developers and operators and the inefficiencies and how we bridge this. And this is, mind you, 2004, before DevOps was invented. DevOps was invented in 2009, and I just worked on that because I thought it's a real problem. You need to believe that what you're addressing is a real problem. It's not just something that you're doing because you can publish a paper about it. And then you need to be persistent. So don't give up. And it's really important to listen and get feedback, but it is also important. What I'm going to say, it's probably not that conservative. It's also important to know who not to listen to. So some people are going to tell you it's bullshit, and sometimes you actually don't need to listen to them. So follow your passion and be persistent. That's my advice, 2 cents.
Yeah. I like that. The follow your passion is something in undergraduate I was told many times. but it never really clicked, I just thought it was one of those, yeah. But later in life, I can really second that if you have the luxury to choose something that you really like to work on, then do that, because that's maybe the only way in which you're really going to be good at it. Another nice piece of advice I got from a mentor of mine, Robert Sokolov at Princeton. He, when I sort of returned to academia after a stint in the private sector, and I told him I want to work on climate change issues, he said, that's great, you're a physicist, you're a mathematician, that works, but just keep in mind, to help the world, there's so many different talents that you can use. You can approach it from math, as a journalist, in art, and also as we see data science, right? So the working on sustainability, data for good, it all comes together, and there's so many different angles. So for students who want to work in this area, don't think that there's only very narrow disciplines or paths where you can apply your talents. Maybe I'll just have one more question for you, and then we'll go to the audience. It's a bit more personal, so feel free to deflect. Well, it's not that personal, but more like self-reflection. So since your research into carbon accounting, has that at all changed your sort of daily decisions in what you do, what you buy, your outlook on the environment?
Yes, so no, it's not too personal. I think almost nothing is too personal for me. I'm a very open, I'm an open book. But before I answer that, I just wanted to say, I totally agree with you about mathematics. And I think critical thinking, analytic thinking is really in the heart of everything. And once you possess that skill, that's why I'm so happy that what I did in Techneo in my PhD was algorithms complexity analysis and the theoretical computer science, because you can really apply them in so many different ways. It's really a skill that I used in everything that I did and I'm still doing. To answer your question, so it's funny, like after I came back from that conference that I told you in 2019 from ICSI, and I was obsessed about climate, I got a lot of advertisements on Facebook and platforms like this for losing weight, losing body weight. And I'm like, why is everyone obsessed about losing their body weight? I'm obsessed about waste. I actually even started a Facebook group which is called Waste Watchers. How can we actually help human beings to control their waste, or to make more healthy choices, not for their body weight, but for Earth. So that was sort of my obsession. And since then, I'm sort of very obsessed about plastic, so not buying plastic. When I go to, it's like an obsession that is sometimes hard on the mind, because when I go to a restaurant, the first thing I do is I count all the plastic bottles on the table. But that's sort of an obsession of mine. So that's me. What about you, Christoph?
It's not so much my lifestyle, but my outlook. I tended to think more systems level. How much, as a physicist, how much does the world have in the bank in terms of natural resources? And then you get to these fascinating sort of hardcore technology solutions. Direct air capture, I find very fascinating. But that doesn't really necessarily empower an individual, so that through data science now we can have fast carbon footprinting and actually help bring transparency to the carbon in products and help consumers make purchasing choices. I find that very encouraging. So thank you. I want to invite Jessica to help us field some questions from the audience, please. Tamar and I will try to keep our answers short to get to a few questions. And Jessica, just let us know how we're doing timing wise and how much time we have left.
No problem. We have a few minutes for Q&A. Let's look at, what do you imagine to be the key incentives for business to share their carbon footprints? Do you imagine these to change in the next few years?
I'll try to take that. So this is a regional question as well. It doesn't, the answer is not going to be the same all around the world. For example, in Europe, there is a movement. It's called the PEF, Product Environmental Footprint, that is currently after piloting in a transition phase. So there might be actual from the European Committee laws, regulations that require companies to do that, to reveal the product carbon footprints of their products. But many companies, I know this in the US specifically, I know this from conversations with Colgate, for example, they are also very much aware of, no, our consumers are asking us more and more about these questions because of this overall momentum. And therefore companies now want to have answers when consumers or watch groups, NGOs, etc., ask those questions. So I think there could be different, there is momentum behind more transparency, but the underlying reason can be different by geography.
Thank you. Okay, our next question. What work has been undertaken to standardize machine-readable data related to product carbon footprints? For example, extendable business reporting language is a freely available and global framework for exchanging business information. Is there an environmental equivalent?
Tamar, do you want to give that a try?
Yes, sure. So there is actually multiple different efforts. The World Business Council for Sustainability Development, they have multiple different activities. And Christoph, I forgot the name of the activity that you mentioned to me. I'm not very good in remembering names, but you mentioned to me specific
They call
activity.
it the Pathfinder Initiative.
Pathfinder, yeah. Pathfinder Initiative, and actually IBM is part of it, is contributing to it. The idea is very important because that goes into the heart of the question of the topic that I alluded to before, which is that we need programmability, and we are implementing an engine to help companies programmatically compute the carbon footprint. And it's going to be different per sector because sectors have different activities. You need different calculators. So this engine must be extensible. And then you must share the data. So it's a recursive process in the sense that somebody is going to consume the data. Based on that data, it's going to be an input to perform their own calculation because they're next in the life cycle. So this is why a standard is so important. And we believe it's a key activity, and that's why IBM is contributing to this activity. And the least that we can do is be able to make sure that we conform to that standard in whatever we're implementing. I want to do more. I also want to open source that engine so that everyone can collaborate and see it. And I think that's going to also contribute to trust in that area.
Well, thank you so much, Christoph and Tamar. This was a great 30 minutes and an important session.